Hello and welcome to our lesson on cube roots with radicals, a more advanced look. Alright, first in definitions. A value of a number or a variable that when you multiply it 3 times in a row, that's the cubic part, will equal the radicand. There's your index of 3, cubic, and there's your radicand of 54. So we would say that we need to find the cube root or the third root right there of the number 54. Now, much like when you have to simplify a radical, you need to make a factor tree for this as well. So 54 would be 9 times 6. Those are not primes, so let's keep breaking them. 3 and 3 are primes, and I put a dot underneath just to keep track of my primes. And then I have 3 and 2. So I've broken down all of it to prime numbers. I've got 3 times 3 times 3 times 2. Now, in this case, it's pairs or groups of 3 stay out and singles have to stay in. 54 is broken down into prime factors, and we just did this. 2 times 3 times 3 times 3. There is a triplet of 3's, so they're going to come out. Let's circle them. Here's a triplet right here of the 3's. And then we've got that single 2, lonely little guy right there, and he's got to stay underneath the radical sign. This is what it would look like. Here comes out that triplet of 3's. You only write it one time to indicate it's a group of 3's. Your index is still 3 because we're looking for cube roots. And that lonely 2 stays back under the radical sign. Now, you need to double check your answers. So, you're going to take the whole number that's outside the radical sign, that was that group of 3's. You're going to multiply it by itself the number of times of the index, and then you're going to multiply that answer by whatever is still underneath the radical sign. If you did it correctly, whatever your answer is should match your original radicand. So here's our whole number of 3. We're going to multiply that whole number of 3, the number of times of the index, 3. So that means we're going to multiply the number 3 times in a row, because 3 times in a row is what the index told us. So we've got 3 times 3 is 9, and 9 times 3 is 27. Now we're going to multiply that answer that we just had, which was 27, by the radicand, which is the number 2. So 27 times 2 equals 54, and that definitely was the original number we started with, which means this answer right here, 3 cube roots of 2, is correct. So let's look at 108 as an example. We're going to take 108 and prime factor it. I know that 2 goes into there 54 times. 2 is prime. 54 is not, so 6 and 9. Let's break them down into 2 and 3. Those are both primes. And then 9 is 3 and 3. Now I'm looking for triples. So I have 1, 2, 3 groups of 3, but I have 2 leftover 2's. So they have to stay inside the radical sign. If I had one more 2, I could take them all out. I only have one group of 3, so they come out. It's to the third root. And I have a pair of 2's that are staying underneath. Let's go ahead and simplify. You have 3 cube rooted 4. And we're going to double check now. This says 3 to the third. So you're going to say 3 times 3 times 3. That's 27. And then you're going to multiply it by your radicand, which is 4. And if you do that, you're going to get 108. It gets you back to your original. So that means right here, 3 cube root of 4 is the correct answer. Now we have a fraction. Let's deal with one part of the fraction at a time. So first we're going to look at the numerator. It's 1. Well, if we take 1 and we factor tree it, it's just 1 times 1. We don't have triples, so it's got to stay underneath. So we end up with cube root of 1. And now we're going to take 54, which is 6 times 9, 2 times 3, now I've got 2 primes, and then 3 times 3. Alright, cube root says find triples. I have triples. And then I have one guy who stays back because he doesn't make a triplet. So the 3 comes out, and notice I put it in the denominator position. That's where it was originally with the 54, so it's got to stay there. And then what stays underneath is the 2. And these are all indexes of 3. Now you could write it like this, or you could write it differently. We have one big radical sign, cube root. And then create your fraction again. 1 goes here. You need a placeholder up here as well. You've got 3, that was your triplet that came out, and then you've got your leftover 2. So you can either write it like this, or you could write it like this. Either way, separate the fractions or keep them as 1, it still works the same way. Let's try another one with fractions. Let's focus on the 24, the numerator first. Break them down randomly. 2 times 12, got a prime. 3 times 4, got another prime, and then 2 times 2. Now I'm looking for triplets. I have 1, 2, and the third guy up here. And then this little 3 is all by himself. So in numerator position, the 3 has to stay underneath because he's by himself. And up here in numerator position, the 2 comes out. Okay, let's move this guy over here. Now if we do the denominator and we break 2 down, it can't be broken down into triplets, so the 2 just stays where it is. So your final answer is going to be 2. 3 was the numerator left over. 2 was the denominator left over, so they've got to stay in the same spot, and you have an index of 3. So this right here would be your final answer. How about that last one? 16. Well, I know that 16 is a perfect square, but I'm not looking for pairs, I'm looking for triplets, so I have to keep breaking them down. I've got 2, 2, 2, and 1 more. Now I'm looking for 3s. 1, 2, 3 are coming out, and the lonely guy is staying in there. So that means that, again, this is all numerator position. My lonely 2, and then my single 2 is coming out, and these are in indexes of 3. Now let's take a look at the 64. Now I'm focused on denominator. I know it's 8 times 8, however, we're not looking for pairs, so we got to keep breaking them down. 4 times 2, 2 times 4, I've got primes, and then 2 more primes. All right, let's look for pairs, or let's look for groups of 3. 1, 2, 3, right there. And then I have 1, 2, 3. 2 groups of 2, no leftovers. So I could write 1 under here, or just not write anything at all. And usually, if you don't have anything under there, you don't write anything under there. So we just leave it off. But over here, I had my 1 group of 2s and my 2 group of 2s, so that's going to be 4. Now we could stop there. However, if you notice, 2/4 can be reduced. So your final answer would actually be 1/2 cube root 2. So far, so good. Let's try it when it involves algebra, which is variables and exponents. Take 104 and we'll break him. I know that 2 goes into there 52 times. 2 is prime. And here I can make him go 2 and 26. 2 and 13. Turns out that 13 is also a prime, so I'm done. I see triplets. And there's a lonely leftover. And then I've got x cubed. Now that exponent really means that's the number of times you write the variable. And look, it's a triplet. Okay, so my 2's are coming out, my x's are coming out, and 13 has to stay in because he's single. So I have a 2, an x, this is to the cube root, and then my lonely 13. That would be my final answer. And I want you on your own to go back and double check that. Let's go and try the second one. I've got 3, can't be broken down any further, so he's going to end up staying underneath, he's a single, and then y to the 4th. So that means we're going to take y 4 times in a row. All right, I'm looking for triplets. Comes out. This is all numerator position, remember, so it's got to stay in the numerator when you write your answer. All right, I have an index of 3, and then I have my numerators. The 3 was a single guy right here, so he's got to stay under. I have a single y, so he stays under as well. And then I have 1 triplet of y, so he'll come out. Now let's look at 54. All right, if we break down 54, it's 6 and 9. 2 and 3 are primes, and then 3 and 3. So I have a pair of 3's coming out, and a 2 staying in. Now, we have 9 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9 y's, and we're looking for 3's. Got 1, 2, and 3 sets of y's. So I can take them all out, and there's nobody left behind. This could be your final answer, but if you do notice, you've got a y up top and a y underneath, so you can reduce them. So if you take a y out, y divided by y, you've got 1. So you've got 1 over, and then if I take a y out of y cubed, I have y squared, and then you have the rest. Cube root 3y over 2. So this would be your fully simplified final answer. We have one more to try out on this page, 24. 2 times 12, 3 times 4, and 2 times 2. And then z to the 7th, please write them all out so you don't drop anybody. 3, 4, 5, 6, 7. We're looking for triplets. I have 1, 2, and a third one, and then the lonely 3. So 2 is coming out. And then for cube root, I have a 3 left over. See how many z's? 3 of them, 3 of them, and a lonely. So I have 2 pairs of z's, so it's coming out as z squared, and I have 1 z left over. So that would be your answer. And naturally, you go back and double check. All right, so let's look at the last problem. We've got 64, and I know that it's a perfect square, but I'm looking for cubes, so I have to keep breaking it until I find triples. And it looks like I found 2 primes, and I found some more primes, and some more primes. All right, now let's look at m to the 10th. I'm focusing only on the numerator first, and I've got 10 m's. Write them all out so you don't end up dropping off anybody. After you do this a couple of times, you won't have to worry so much about listing them all. Now, index says 3, so I'm looking at 1, 2, 3, and then I have 1, 2, 3. I have 2 groups of 2. So on the outside, I've got 4, because it's 2 times 2. This is all in the numerator. And then I've got radicand 3, and here I've got 3, 6, 9. So those are all groups of 3. So 1, 2, 3 groups of 3, and a lonely leftover. So I have m to the 3rd and a lonely leftover. These were all numerator position. Now let's look at denominator. Okay, it's got 16, which is 4 times 4, and 2 times 2, and 2 times 2. 1, 2, 3, 4. Got 1 group and a lonely leftover. 1 group of 2's and a lonely leftover. And then I've got 4 m's. 1, 2, 3, 4. 1 group of m's and a lonely leftover. 1 group of m's and a lonely leftover. However, there's some reducing that can go on here. I've got 4 over 2. I've got m to the 3rd over m. I've got m over m. So, I can take 4 over 2. 4 divided by 2 is simply 2. I've got m cubed up here and m on the bottom. So remember, if you divide exponents, you don't. You actually subtract it. So it's 3 minus 2. So I just 3 minus 1, so it's m squared. And then I've got, this is all cube roots. And I can just leave what's underneath the radical. I can just leave it be. So this right here, in the middle of all this stuff, right here, that would be your final answer. And then you go back and you double check and make sure that you did it correctly. A quick review. In order to find cube roots of radical expressions, first make that factor tree of the radicand. After all your prime numbers can be tripled up because it was cube root, you take them all out of the radical sign. Any remaining ones that couldn't turn into triples, go back under the radical sign and they get all multiplied together and they create your brand new radicand. You do the same thing for your exponents and your variables. List out your variables, circle how many groups of 3's that you have, take them out. Any leftovers, back under the radical. Be sure to go back and double check all of your answers. And that's it for our lesson on radicals, cube roots, a more advanced look.